Good morning, champions. In today's class, we will try and understand about the bonding in carbon. But before we start understanding about the bonding in carbon, let us try and understand why elements react with each other. What is the reason why they react with each other, right? So we will begin the class with this question: why elements react with each other? And the answer is obvious, right? The elements react with each other to acquire the nearest noble gas configuration so that they become stable, right? So all the elements react with each other to gain the stability. So elements react with each other to acquire nearest noble gas electronic configuration to become stable. So for stability, right, stability, all the elements react with each other. And in the first term, you have learned about the ionic bond, right? Ionic bonds are formed by the complete transfer of electrons. Either electrons are gained or loosed by the elements to form that ionic bond, right? Now we will look for the possibility of carbon, whether carbon can form ionic bond or not, right? So before we understand, let us have a look on the electronic configuration of carbon. It is 2, 4. It has 2 electrons in the first cell and 4 electrons in the second cell. And the nearest noble gases for carbon are helium 2, and the next one is neon 10. So in order to gain the stability, carbon has to either gain the electronic configuration of helium or to gain the electronic configuration of neon. These are the nearest noble gases for the carbon, right? So we are assuming two conditions, right? We are assuming, but before that, one question, that is, how does carbon acquire its nearest noble gas electronic configuration? Right. So first of all, we are trying to understand whether carbon can form ionic bond or not. We are assuming whether carbon can form ionic bond or not. Right. So there are two possibilities for the carbon to form ionic bond. That is case 1, C4 plus ion. Carbon could form C4 plus ion by losing 4 electrons That is, by losing 4 electrons, carbon could gain the nearest noble gas configuration of helium, right? But to do so, carbon required a large amount of energy, isn't it? To do so, carbon atom required large amount of energy. So this is not possible for the carbon. So we see that formation of C4 plus ion is not possible for the carbon. Carbon cannot lose 4 electrons. Why? Because the requirement of energy is very high. Now, we are assuming the second case where the carbon can form C4 minus ion, case 2. Carbon could form C4 minus ion by gaining 4 electrons. By gaining 4 electrons, carbon could become 4 minus ion and could acquire the nearest noble gas configuration of neon. Right. But even in this case, after gaining 4 electrons, the number of electrons becomes 10, whereas the number of protons remains same, that is 6 protons, right? So in this case, a nucleus with 6 protons cannot hold on 10 electrons. So it is also not possible for the carbon. So we can see that by understanding the formation of C4 plus and C4 minus ion, right, which is not possible for the carbon, we can conclude that carbon can neither gain nor lose electrons, right? So definitely carbon cannot form ionic bond. Carbon cannot gain or lose electrons to form bond. So what will carbon do? Right? These two cases, these two conditions are not possible for the carbon. It means carbon cannot lose electrons or gain electrons. Right? So to overcome this problem, carbon decided to form the compound or the bond by the sharing of electrons. Right? That we will understand in covalent bonding. Now, champions, you are able to answer the question why carbon cannot form ionic bond. Now, we have seen the two cases to overcome these problems. Carbon opted to form the bond by the sharing of electrons, right? To overcome this problem, carbon opted, or you can say decided to form bond by the sharing of electrons. So, carbon gains its nearest noble gas configuration. Carbon acquires its nearest noble gas electronic configuration by the sharing of electrons with other atoms, right? So the carbon opted for the sharing of electrons to gain the nearest noble gas configuration and become stable, isn't it? So a bond will form in this manner. So the bond formed in this manner is called covalent bond. Let us try and understand covalent bond. The chemical bond formed by the sharing of electrons mutually between two atoms is called covalent bond. So the covalent bond is formed by the sharing of electrons mutually between two atoms, right? So this kind of bond is always formed by the mutual sharing of electrons, and mutual sharing means, right, if one shares the electrons of other, the other will also share the equal number of electrons of the first, right? Take a simple example, the formation of H2O. There is not only carbon which forms covalent bond, there are many more other elements which forms covalent bonding, especially nonmetals. Take example of water, that is H2O. Hydrogen has one electron and it wants to gain the nearest noble gas configuration of helium. Oxygen has 8 electrons. It will gain the nearest noble gas configuration of neon, that is 10. So hydrogen has to share one electrons to become 2, and oxygen will also share 2 electrons, right, to get the nearest noble gas configuration of neon. So in S2O, oxygen atoms shares one electron of each hydrogen atom, and in turn hydrogen also shares one electrons of oxygen. Each hydrogen atom shares one electrons of oxygen. So here, these electrons are mutually shared between oxygen and hydrogen, right? So in this way, oxygen has completed 2 to 4, right, and to 8. So it has completed, oxygen has completed its octet, right, by sharing one electrons from each hydrogen atom, and hydrogen has completed its duplet, that is the nearest noble gas configuration, by sharing one electrons. So this is called mutual sharing, right? So in this way, a bond is established between oxygen and hydrogen. It is HOH. The electrons are always shared in pair, and these electrons are called shared pair. During formation of covalent bond, electrons are always shared in pair. So remember one thing, and this pair of electrons are called shared pair electrons, right? So in the covalent bonding is a bond which is formed by the sharing of electrons. We'll take some more examples of the covalent bond. Now we will see some more examples, right, of covalent bond. We are taking the first example of ethane, that is molecular formula C2H6, and we will see the mutual sharing of electrons. The hydrogen will complete its duplet, so it required only one electrons, right? And that the hydrogen shares with the electrons of carbon. In turn, carbon also shares the electrons. So everywhere you can say there is a sharing of single pair of electrons everywhere, right? And between the carbon also. So in this example, that is in ethane, right? Carbon, hydrogen, and carbon, carbon all are bonded by sharing one electrons of each, right? And this type of covalent bond, the covalent bond formed by the sharing of a single pair of electrons is called single covalent bond. So we can say that in ethane, each atom is singly bonded, bonded by the single covalent bond. That is, carbon-carbon bond is also single, and each hydrogen atom is also singly bonded to the carbon. So this kind of bond, a bond which is formed by the sharing of a single pair of electrons, right? Everywhere you will see that there is only single pair, sharing of one electrons from each atom. That is called a pair of electrons, and there is a sharing of single pair of electrons everywhere. If we look for two atoms, hydrogen, carbon, there is only a pair of electrons shared between them. So this kind of covalent bond is called single covalent bond. Whereas in the second example, ethene, sharing of electrons between hydrogen and carbon is just a single pair. So hydrogen is bonded with the carbon atom by single covalent bond, but the sharing of electrons between, see the sharing of electrons between the carbons. They are mutually sharing two electrons of each. It means double pair of electrons. So the bond formed by the covalent bond, that is formed by the sharing of double pair of electrons, is called double covalent bond. The bond, the covalent bond, formed by the sharing of double pair of electrons, is called double covalent bond. So in ethene, there is double bond between carbon atoms, but hydrogen atoms are singly bonded. That's why I have told you that whenever we are looking for the sharing of electrons and types of covalent bond, we just consider two atoms at a time. Here we are considering carbon and hydrogen and looking for the sharing of electrons. So one pair of electrons are shared. That's why hydrogen and carbon here are singly bonded. It means bonded by a single covalent bond. But when we consider two atoms of carbon, we see that a double pair of electrons are shared between them. It means two electrons from each, that is total four electrons. So this kind of bond is called double covalent bond. So in ethene, carbon are bonded by the double covalent bond and hydrogen by single covalent bond. Now, coming to our third example, that is ethane, right? So, in ethane, we see that there are sharing of three pairs of electrons between carbon atoms, right? It means total six electrons. So, the bond which is formed by the sharing of three pairs of electrons is called triple covalent bond. Right. So in ethane, carbon atoms are bonded by triple covalent bond and carbon hydrogen bonded by single covalent bond. So in these three examples, we have not only understand how mutual sharings of electrons takes place, but we have also understand the types of covalent bond, that is single covalent bond, double covalent bond, and triple covalent bond. Right. Uh, this topic will elaborate in higher classes, but as per the 10th syllabus, you have to keep uh, in focus single covalent bond, double covalent bond, and triple covalent bond, that you will come across while you are dealing with the hydrocarbons, right? That will be our next topic. So the covalent bond is a bond which is formed by the sharing of electrons, and there are three types of covalent bond, that is single covalent bond, double covalent bond, and triple covalent bond. Now we will quickly see some more examples. Like in hydrogen, each hydrogen atom is sharing one electrons of each and forming a single covalent bond. In oxygen molecule, each oxygen atom is sharing, right, two electrons of each, and that is double covalent bond. So it is the bonding between the oxygen atoms in O2 molecule is double. So it is doubly bonded oxygen atom. In nitrogen, each nitrogen atom shares three electrons of each. It means there are three uh, pair of electrons shared between two nitrogens. So in nitrogen molecule, nitrogen atoms are bonded by triple covalent bond. In CO2, oxygen and carbon, that is the sharing of electrons between oxygen and carbon, They are sharing two pairs of electrons, so they are also bonded by double covalent bond. In ammonia, right, each hydrogen atom is bonded to the nitrogen atom by single covalent bond because there is only one pair of electrons shared between each atom of hydrogen and nitrogen. In HCl again, chlorine completed its octet by sharing one electron of hydrogen, and in turn hydrogen also shares electron of chlorine, and in HCl hydrogen and chlorines are bonded by single covalent bond, right? So champions, we have understand about the covalent bonding, right? Now we will understand about the covalent bond, covalent compounds and their characteristics, right? So what are covalent compounds? Simply the compounds formed by covalent bonding are called covalent compounds. So it is very simple to define about the covalent compound. The covalently bonded compounds are called covalent compounds. For example, water, carbon dioxide, ammonia, etc. So there are large number of covalently bonded compounds, right? So we will not try to understand the some of the characteristic properties of covalent compounds, right? So properties. So the first characteristic feature is they are formed by covalent bonding. They are mostly the compound of nonmetals. Since they do not ionize, usually ionized, they do not conduct electricity. They have weak intramolecular force attraction. So most of them are in gaseous or in liquid state. they have low melting and boiling point. It is also because of the weaker intermolecular force of attraction. So these are some characteristic properties of covalent compounds. Now let us recap once again. So covalent compound, the compounds which are formed by the covalent bonding, that is called covalent compounds. For example, these are the covalently bonded compounds S2O, CO2, NS3, etc. Now, there are some properties of covalent compounds, right? The properties are they are formed by the covalent bonding. They are mostly compounds of nonmetals that do not conduct electricity because they do not ionize. And we know that for the conduction of electrons, for the conduction of electricity, free electrons or ions are required. So they do not ionize. Hence, these type of compound, that is covalently bonded compounds, do not conduct electricity. They have weak intermolecular force of attraction, right? Because of the intramolecular force of attraction is weak, right? They are mostly found in gaseous and in liquid state. Because of the same reason, because the weaker intermolecular force of attraction, they have low melting and boiling point. So in this way, we come to the end of this class, right? And we have understand about the bonding in corpus. I will give you one question to answer. That is, question is differentiate between covalent compounds and ionic compounds. So that is the question. So you must have a comparative view of covalent compounds and ionic compounds. Thank you. Bye bye.